So P-series test, that one's hopefully you didn't find it too crazy. You just need your P, it has to be in the correct form. Direct comparison test can be easy if it's like a easy series, like not super complicated, especially when you compare it to a P-series. But then like the direct comparison, you have to know like which one's like above and below. So sometimes that like hurts the brain. Limit comparison, it's a lot of algebra and taking limits, but it's pretty like solid. You don't have to worry about things being above or below. And then if you can compare it to geometric or P-series or something like that, then it's pretty easy. So limit comparison doesn't work. Like you can't use it for alternating. So alternating series is ones that like change from like positive to negative, basically. So like the ones, the easiest ones to tell are when they have the little -1 to the end thing. That's pretty like standard. It's going to be alternating because you're changing, like when n is odd, it's negative, even, positive. Same kind of idea with that. Odd and even, or this one, -1. They don't really make too much of a difference. Either way, it's going to change from positive, negative, positive, negative. This one is sneaky though, like the sine cosine ones. That's a sneaky alternating because it changes, because the function oscillates. So technically it changes, like think when you plug in 0, it's negative. You plug in 0, it's positive. You plug in 1, it's negative when you have that set up. So those ones can be like a little sassy. I don't see them I don't see that very often on free response. I usually see it on multiple choice. Like they'll say which one's an alternating series. So just keep in mind anything that changes positive, negative is alternating. Alternating series test is really easy until we get to tomorrow. So it's really not bad. It doesn't take a long time, which is why I don't mind it. So this is technically test number 8. But the problem with this one, like I said, is like once you decide that it's convergent, you have to now figure out more things, and that's what tomorrow is. So basically what you do is the first thing is you take out the non-alternating stuff. So basically ignore the -1 thing. So pick, keep the -1 out. And the first step is to see that those terms go to 0. That's the first test. And the second one looks all fancy. But it's basically means like it's non-increasing. So like the terms are like going down. So like 1 and 2 are honestly very similar on what you're talking about, but like you have to prove it with that notation. So I'll show you examples because right now it seems kind of weird. Okay, so this first one, determine the convergence or divergence of the given series. So the first thing you do is you find the the non-1 stuff. So you just take that part out so you don't really focus on the -1 thing. And then kind of notice, okay, you don't need to write this, but I'm noticing A sub n is 1 over n. Okay, it's like the non-1 stuff, right? So the first thing you do is you check, you show that like, hey, the limit to infinity of 1 over n equals 0. You're like, thank you. That a lot of you can do that in your head, but you have to like show it to be legit, okay? And then the second step, it's really not like too bad. You have to show that the next term is going to be smaller or equal to the term before it. That's essentially what it's saying. So like the terms are getting smaller as you go. So like what you have to do is show that you're plugging in n plus 1 basically. So like if you plug in 1 over, and then you're going to be plugging in n plus 1 into the series is smaller than 1 over n. So the denominator is bigger, right, than this one, so this one is smaller. So you just prove that it's non-increasing, so you're going to say this converges. So this one kind of throws people though, because if you look at, like if you looked at the series 1 over n, that would diverge because it's harmonic. But because it's alternating, okay, because it's alternating, this series converges. It kind of like hurts the brain because you get them mixed up. So alternating series is take it to the 0, plug in n plus 1, double check that the next term is smaller. It almost always is if this one goes to 0, and then that means it converges. Okay. Now you look at 2, so you just look at the non-negative 1 thing. So it's literally that. It's not like too complicated. So you're going to take this guy, and then step 1 is the limit as n goes to infinity of n over n plus 1, and you take the limit, and you're like, oh, it equals 1, which isn't 0, right? So you have to like show that you're recognizing, hey, not 0, right? So this diverges. This one, you could say, I mean, technically it's going back. This would be technically nth term test. So like step 1 is like seeing if it passes or if it doesn't work for the nth term test in a way. So if it equals a number or it's not 0, that's technically nth term test from like way back when. So. All right? Okay. Ratio tests. This we're going to be obsessed with even in Unit 10. Okay? So, this guy's real algebra-y, but it's very, very popular. Okay? So, test number 9. Okay, so basically what they do for ratio test is they compare the term with n with one more term after. Okay, so they do, it's a ratio, so it's like a fraction, right? So it converges if these two terms are less than 1. So think about it like they're not so different. Maybe that's how I think about it. So it converges because the terms aren't so different from each other. That's kind of how I remember it. So less than 1 means they're going to converge, and they're going to diverge if it's greater than 1. And obviously, if it equals infinity, then that's bigger than 1, right? So anything bigger than 1, it's going to diverge. If it equals 1, it's inconclusive, which is sad, because that has happened. Ratio test, I usually use with factorial ones. So, or ones with like, well, you can see these examples. Like they're kind of mixing like P-series and geometric-y kind of stuff together. So it's like, what am I going to compare it to? It's like hard to tell what I would compare it to. Because usually I like my limit comparison. If it's like fancy or complicated, I do limit comparison test or ratio test. So like this one, it's hard to tell what to compare it to. That's how I know I'm going to do ratio. It's kind of painful though, ratio test, just because you're dealing with like kind of a lot of algebra. But we'll be fine, right? Okay. So this is what you do. You basically take... You plug in n plus 1, and that's going to be your numerator, and then your denominator is like the original, like the normal one. So it's basically you're going to take, and this part's annoying too because you have to like keep the bars the whole time. And then you have to show that you're taking a ratio to start, even though like every single time you're going to multiply by the reciprocal. So the first one, you're doing the n plus 1 on the numerator thing for all of these. So it's basically going to be 2 to the n plus 1 all over n plus 1 to the factorial. So that'll be your first one. And then the denominator is always like the normal one that you started with. So honestly, this is I hate this first step. Otherwise, it's not horrible. Because now it's just hardcore algebra. But then you have, I don't know how, I mean, we'll go over it, but like how familiar you are with factorials is like another story. So basically what you do is you keep your limits coming. And you're going to go multiply by the reciprocal. Okay, so we multiply by the reciprocal, cool, right? So now, what I'm going to do, so this is what my brain does, is because it's all multiplying, I just kind of put all the 2 stuff together and then the factorial stuff together. So the first thing is I'm going to compare these guys, which you guys already had some practice with. You know, like 2 to the n plus 1 divided by 2 to the n, and then I'm just going to kind of group all this junk together, basically. I mean, you don't really need to show that step, but I'm just for the notes, right? Okay, so that first guy, you've kind of, like I said, you've done this a little bit already, but like you're doing like backwards exponents, you know? So you know how like this is x to the 5th, right? You like add them. Now you're going backwards. So 2 to the n plus 1 is 2 to the n times 2 to the 1. Right? So I broke up the n plus 1 thing. And then you can see how you're left with just a 2. So you have an extra 2 on the numerator. Right, so maybe I'll start right the next one too. So you're left with a 2 from that first guy. So this guy turns into the 2, right? Now this one takes maybe a little bit more brain power. Actually, erase this thing. Okay, so for the factorials, think of if it was 4 factorial over 5 factorial. Think about what that means. Because 4 factorial would be 4 times 3 times 2 times 1. And then 5 would be 5 times 4 times 3 times 2 times 1. So basically, a ton of stuff divides out. Right? Because you've got, obviously the 1s don't matter, but the 2s, the 3s, the 4s, so you're left with 1/5. So 4 factorial divided by 5 factorial is 1/5. So if you had to do this like n plus 1, which is all fancy, you know? So if you had n factorial over n plus 1 factorial, the way the numerator would go would be n times, and then the next term is like 1 less, because you know how it was 4, then 3, so you go down 1. So the way you write that out is n minus 1. So it's like 4, 3, minus 1, and then it's n minus 2, and then n minus 3, and dot, 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 right? Whereas n plus 1, so this one's kind of weird because you start with n plus 1, but you're still going down, right? So like the next one after it is you subtract 1, just like the top. So then it just turns to regular n. So you can kind of see that it'll eventually kind of go away. And then you got that one. And then you got this one. And then you just keep going. So when you're taking the ratio of them, all these dot, dot, dots divide out. The n minus 2, the n minus 1, the n. So that second guy turns into 1 over n plus 1. So you're going to do that a lot with the factorials, like working with them. So just, if you want, just start writing them out, or write one that's like with actual numbers, so it's like easier to think about. Okay. So then you can actually take the limit once you simplify it. I mean, you can put them together, but you don't really need to. So if you take that to infinity, you're going to get 0, which, thank God, is not 1. Because if it's 1, it's sad, because it's inconclusive and I got to do something else. So it's less than 1, so that means it's going to converge by ratio test. Okay. So it's just more algebra heavy. Okay. All right. Again, so like number 4, it's too hard to figure out what to compare it to, because it's like geometric-y and p-series, kind of, but not, because it's on the numerator, so it's kind of weird. So I'm going to do ratio tests. So hefty on the algebra. Probably the worst thing I don't like doing is that I have to write it as a ratio first, even though I'm always going to end up multiplying by the reciprocal. So that part drives me insane, but it's fine. Oh, whoops. I need more room here. So you're going to plug in n plus 1 for n. So if you already got like plus 1s on there, that's going to be n plus 2, right? Because you're plugging in n plus 1 into that. So it's going to be n plus 2 all over 3 to the n plus 1. And then your original. So then you're going to multiply by the reciprocal, which you do every single time, but you got to show that you're doing a ratio. So whatever, you got to suck it up. Okay, so we get n plus 1 squared to the n plus 2, 3 to the n plus 1 times 3 to the n over n squared. Whew. Okay. Now don't go so wild slashing things. Okay. Like for example, that n plus 1 quantity squared compared to n squared, you can't start canceling that. That's not legal algebra. Okay. You can deal with the 2's and the 3's. That's fine. Because those are, you've got like more 2's on the numerator, more 3's on the denominator. So here we have, maybe I'll put these in different colors. So like with the 2's, you've got an extra 1 on the numerator, right? Because you have the plus 2 on the top and then the plus 1 on the bottom. So you got a 2 on the numerator. Okay, then we've got, for the 3's, you got an extra on the denominator, right? So we'll do that. And then the other stuff with that n plus 1 quantity squared over n squared, you can't start canceling that out. Okay? But when you take the limit, that's like a different story. I'm not like algebraically crossing these out, but if I take the limit to infinity, they both have technically an n squared on the numerator and an n squared on the denominator. So this equals 2/3, which is less than 1, so this converges. And the way I remember less than 1, again, is like they're not so different from each other. That's how I kind of remember it. I don't know. Okay. Any questions so far, like where any of the numbers are coming from? I don't know. This one's pretty famous, though, this guy. Okay. All right, so this is like n threw up everywhere, right? So we're going to, this is like weirdly, this n plus 1 business is going to be interesting because the numerator is like a double whammy with this plus 1 thing. And this is n plus 1 factorial all over the original. So again, the first step is super annoying. So as long as you accept it, it's just fine. Okay? Because now the real work is when you multiply by the reciprocal. But what's tough on this one is not like a ton of stuff can like go away, which is going to be interesting. Okay, so what does this turn into? This is n plus 1. And then n factorial. So like this one, I like think more things can like go away. But this, it's kind of like that x squared one or the n squared one, like up here. I can't like cancel these, you know. It's kind of the same with this, and the exponents are all wild looking. So we're just not gonna, we're just gonna ignore that for now and just work on these guys. So that's like that first one we did, the factorials, right? So remember how it goes n, then n minus 1, then n minus 2, n minus 3, and then the denominator goes n plus 1, then n minus 1. So basically you're only left with the first term. So you're left with an n plus 1 on the denominator. Okay, so maybe I'll write this down here. And then that n plus 1 I'm just kind of in denial about right now. So we're just going to go with that. Okay, so, oh, and this is kind of weird. This will be fine. Because okay, so we got an n plus 1, and then we have an n plus, so that thing's kind of scary. But with the pink stuff, you know how we got left with an n plus 1 on the denominator? Well, technically, and this thing, right? But do you see how now you can reduce that? Do you see what I mean? Because you've got 2 n plus 1, so you're going to get rid of one of them to divide it out. Is everyone okay with that? Because there's just like no numbers in this problem right now. Because then we've got limit n goes to infinity. So this is what we've got. N plus 1 to the n all over n to the n. Okay. Are we still alive? Okay. So for this one, okay, we have, like, if this was a 2, I would like my life a lot more, you know. Actually, no, I wouldn't, because it would be inconclusive, right? Because it would equal 1. So you have to do fancy things on this one. And this is where you can just pull things out of your brain. You ready? I know, I'm sorry. You guys just so smart. You can just like, everything just comes out of your head. Okay, so this is what I'm going to do. Okay, and I'm going to drop the bars, and I'll show you why in a sec. I'm going to write it, as n plus 1 over n to the nth. Okay, now why can I drop the bars? Think about your n's going to infinity, right? So you're plugging in numbers. Because like your n starts at 1, right? And you're going to infinity. So you're only plugging in positive stuff, right? So this whole limit is always, this whole thing is always going to be greater than 1, right? Now, technically, you could stop there. Technically, okay, you could stop there. But if you want to be extra and cool, you can recognize it as something, which they've put on multiple choice in fancy ways. You ready? Ready? Or just wait. Okay. Now I'm going to do some finagling with the algebra, aka just divide both of them by n. So I get 1 plus 1 over n to the n, right? Which is crazy, crazy famous. We've done it already on the first day. Nope. It's, nope. Nope. It's Euler's number. E. Yep.
No, you're right. Because y1.
This you have to put in your brain, okay, if we haven't already. We did it on day 1 of the unit, but it's E, okay? And because it's greater than 1, whoopsie, again, ran out of room, it diverges by ratio test. Okay, now, side note, okay, ratio test, I did this one on here because you can get the E and it's so like cool and fun. I wouldn't use ratio test though. What test would you use? Nth term, but you have to think a lot for nth term. Because if I took that to infinity, you're taking infinity times on the numerator, whereas this one you're going to infinity times infinity minus 1 times infinity minus 2. So this is greater than 0. So it goes to infinity. So like if I did nth term, I'm basically just doing this. And this equals infinity because the numerator is larger, grows faster. So